Hi everyone, Colin here with Team Align. Today I'm going to do a build video on the TRX 800E Trekker. I've got it here completed behind me. It's a complete package from Align. It comes with the brushless high voltage servos, a 3GX flybarless unit, the 750MX motor, and the Castle 120 HV speed control. A few building tools you'll need is a ruler or a caliper to measure your linkages and hardware, and a set of Allen keys. The grease and Loctite is included with the kit. At this point, you can sit back, enjoy the build video, and gain a little bit of insight as to how it goes together and what comes with the kit. There's no surprises here when you open the box. This is typical Align packaging. We've got everything laid out nice and neat. In this large box, we've got the canopy, our instruction manual, our plastic electronics tray for the front, our forward tail case. In this box, just as it's labeled, we've got our main blades. This kit came with the new main blades, the new style 3Gs. We've got our tailboom supports torque tube. In this box labeled electronic device, you're going to find the motor, speed control, and servos. Over here we've got our 3GX included flybarless unit and our main rotor head components, as well as some of our tail rotor components. First thing I'm going to do is open up the canopy box, take out the manual, and we're going to follow that step by step and go from there. In the box labeled canopy, obviously you're going to find your canopy. This is pre-painted from the factory from Align. Just for a size reference, I've got a stock 700 DFC canopy up here on the top. This thing absolutely dwarfs the 700. Put that to the side. In here we've got our forward tail rotor case. It actually comes with the new black upgraded gears, so you get the stock white ones plus the additional black set, which is nice. You don't necessarily have to use the black ones right off the get-go. You can keep them as a spare if you'd like, or again, you can put them in. We have the plastic forward avionics, or electronics tray we'll call it. Some Velcro links, a little bit of hardware, and our blade holder, along with the skids. The most important piece of this box is the manual. So I'm going to open this up to page 1, and we're going to move forward with the build. Step number 1 for the 800 is to completely disassemble the rotor head, apply some grease to the thrust bearings as you can see here, and then reinstall everything with Loctite. As you can see from the factory, it is assembled, but it's not actually built. Everything's loose. The steel posts going into our control arms here are just threaded in by a couple threads. So you're going to disassemble everything, clean all the threads off with alcohol, and then red Loctite them back into their respective holes. The thrust bearing in Align kits is positioned in between the two radial bearings. This is for better support. The further apart the radial bearings are from one another, the less teeter action you'll get on the feathering shaft. It's very simple to get this bearing out. You can see it right here in the front. All you have to do is, with an Allen key, gently push on the bearing from the back side, and you'll have it in your hand out at the front. Then you've got very easy access to your thrust bearing. So I'm going to take the thrust bearing out. As you can see, there's a little bit of grease in it from Align, but I would like to put some more in. So we'll go ahead and fill it with grease, then reinstall it, and after I reinstall it, I'm going to put a little bit of red Loctite around the outer race of this radial bearing. So once it's in that grip, it's going to be, I won't say permanently fixed to it, but much better than just pressed in. That way any wear is going to be minimized by having this bonded to the inside of the grip. One thing that you need to be aware of is that there's a thrust washer that goes between your thrust bearing and your radial bearing. Sometimes that can get stuck just with a little bit of grease to one of the races of your thrust bearing when you take it out. So just make sure that goes back in the right position. What this does is transfers the thrust load from the inner race of your radial bearing to your thrust bearing so it can do its job. You definitely don't want to be the guy at the field that forgets to install this and throws a main rotor grip because of it. It's something that can easily be overseen, but it is outlined in the manual, so if you're following the pictures and the exploded views, it shouldn't be a problem. But once again, something that's very easy to miss and definitely something you need to be careful of. Step number 2 involves assembling the swash plate balls and installing the main shaft into the rotor head. First, you need to build up your swash plate and slide it over the main shaft before you can install the rotor head. If you install the rotor head first, there's no way that you'll get the swash plate up underneath it because of the lip that's machined onto the main shaft. That lip is there to prevent the main shaft from pulling down through the upper bearing. So instead of there being a traditional collar, we're going to shim the height of this so that there's no up and down play all said and done. Next is our mainframe assembly. As you can tell, this is a little bit more involved than what a typical 700 build is. We've got 3 bearing blocks for our main shaft, our motor mount, pinion support, and our 2 carbon frame braces. So I'm going to assemble one half of the frame, and then we'll put or overlay the other half over this one. I find that's the easiest way to do it. All you need to do is follow the exploded view in the manual. It gives you references for what screws are what, the dimensions, where they go. So I'm going to build this up. We'll do a step-by-step picture take, and then once that's done, we'll review it and explain some of the features of it. Here's our completed main frame. I've got the included stock motor, the 750MX, bolted into the frame here. As you can tell, the frame bracing on this is substantial in comparison to a 700. We've got, just like on the 700, a single piece aluminum base plate. It's milled out to be a little bit lighter, but this is definitely more heavy duty, a little bit more rigid than what you're going to find on the 700. We have a 4mm frame brace here, 3 bearing blocks, just like the 700 has. Back here we've got 2 carbon fiber frame braces that are going to double as mounting locations for could be your 3GX and APS. If you're using a different flybarless system or GPS system, there's lots of spots to mount stuff. I'm going to choose to mount my speed control up here. The wires for my motor are going to run right back to the speed control, so it'll be a nice tidy setup. The bottom tray is quite a bit bigger than what the 700 has to allow you to run larger battery packs if you do so choose. I'm going to be using a 12S setup. I'm going to move forward and install the electronics tray here on the front, the tail transmission here on the back, and then we'll get into assembling the tail components. Like I mentioned before, the tail case does come with the older style white gears, and it also comes with the new style black gears. You can choose to either swap them out if you'd like, or just throw these in a parts bin and keep them as a spare in case you do ever crash or hit the tail on the ground and strip out your tail gears. At this point I'm ready to build up our CCPM bell crank control system. I'm going to install the control balls on the bell cranks, and then we'll view how to install it into the frame set. With the bell cranks built, we can install it into the main frame. The first thing you're going to need is one of your aileron bell cranks and the through shaft or cross shaft. So you slide your bell crank over the cross shaft, then you'll grab one of the aluminum spacers and slide it over the cross shaft. This is what's going to space this bell crank out from the bearing on your frame. Now also included are several small shims. These shims are what you're going to add in between this spacer and the bearing to remove any in and out play that you may have once everything's tightened up. So we've got this together. Then you'll position your anti-rotation elevator or 4-aft bell crank, we'll call it, in between the frames, and then just simply slide the cross shaft through the bearing, through the A-arm, and then out the other side. Once it's out the other side, you'll do the exact same thing that we just did here to the opposite side. Tighten up both of these screws and then add shims as necessary to remove any in and out play. Now we're ready to install the included high voltage brushless servos. The manual does give you some recommended linkage lengths. You need to follow those for the initial setup. Once we have the servos in the main frame of the helicopter, you can tweak the linkages accordingly to make sure that there's no binding between the servo horns on the servo and the balls of the bell crank. I'm going to go ahead and install these. They're pretty straightforward. It's just 4 screws into the frame of the helicopter, and then we'll visit the linkage setup. On our far left over here, we've got the Swash plate to bell crank linkages, which are very robust. They use the shorter lengths with the aluminum reinforcement ring over them. Next, we have the carbon reinforcements for our servo to bell crank rods, along with the aluminum caps and the links. To build up this rod, all you need to do is grab a rod and a carbon piece, slide the carbon tube over the rod, then grab one of your aluminum caps, push it over, and then simply install your link on either end. You do that for the other end. Obviously you're going to have to do that 4 times, and then you can set them to the length that's recommended in the manual and adjust them further once you've got your servos mounted, your flybarless unit on, and all your servos are centered. With the servos in our main frame, we're ready to install the main gear and tail drive gear along with the main shaft and rotor head. The kit does come with the new stronger black main gears. They're a little bit more rigid and a little bit tougher. You can either choose to use the included white gear, this is the standard setup, or the upgraded stronger gears. In this case, I'm going to use the white plastic gears. I've personally never had an issue with them, and I'm going to save these as crash parts in case I ever have an incident with it. Like all Align kits, you're going to have 4 included main shaft shims of different thicknesses. You're going to shim the height of the main shaft, just like we did with the control system cross shaft, so there's no up and down play once the lower main shaft bolt is installed through the tail drive gear. I'm now ready to start with the rear tail box. As you can see, the tail case comes pre-assembled and it has the white standard gears installed in it. Just like before, it does include the black upgraded gears. I'm going to use them because the tail hub is actually beefier than what comes on the standard shaft. It is a bigger helicopter. I'm going to be running 115mm tail blades opposed to 105, so the added stress of the longer tail blades, larger helicopter in general, just for safety matters, I'm going to go with the larger hub. I don't think that there's going to be an issue with this, but once again, it is an 800 size helicopter. It comes with the kit, so you're probably better off in this instance to use the upgraded gears. With our tail case complete, we can prep the torque tube for installation into the tail boom. The first thing you need to do is glue your support bearings to the torque tube. All you have to do is slide it over the torque tube and apply a little bit of crazy glue to hold it in place. Once it's dried, you can install your support, the rubber support that's going to house the bearing inside the tail boom, over the bearing. So you'll just slide this over, up over the bearing, and then apply a little bit of the clear line grease to the rubber holder and then slide it in through the tail boom. When you're installing the boom supports on the model, make sure that you have your tail boom or tail fin clamp loose enough that you can slide it back and forth. Don't tighten these until you get these boom supports fully tightened onto the bracket so that everything's lined up and that you can look down the tail boom and ensure that that's lined up with the main frame. This realistically is just a cosmetic thing, but you definitely need to make sure that you're not pulling or pushing, compressing these boom supports when they get bolted onto this clamp. Canopy assembly is pretty straightforward. You've got 4 included black plastic canopy protectors and then 4 white grommets. All you need to do is take a little bit of crazy glue and glue the plastic protector either on the outside of the canopy or the inside of the canopy. I think it looks a little bit cleaner glued onto the inside, so I'm going to apply some crazy glue, let that set up, make sure it's completely dry before you try to put in your grommets. Otherwise you will push this out and then you're just left with a big mess of glue and you'll have to clean it up and start from scratch again. So glue these in, let them set up, then install the grommets. That concludes our 800E Trekker build video from Align. Behind me here I've got my TRX 700E just for a size comparison. It's very versatile in the sense that it's designed for 3D and also can be combined with the Align camera gimbal to carry some very heavy HD camera equipment. Once again, it is geared toward 3D as well. It shares the same power system as the 700E, so it's very economical for an 800 size helicopter. In lieu of that, it's not going to have quite the same power to weight ratio, but the extremely light disc loading is going to make it float much more than the 700E does. So once again, I hope you enjoyed the build video, and I'll catch you next time. Thanks for watching.